All right, today we're going to combine your knowledge of quadratics that we've just been reviewing with inequalities. And we're pretty familiar with inequalities. You're dealing with greater than, less than, equal to. And a few things to note is that quadratic inequalities either have 0, 1, or infinitely many solutions. And the way we describe those solutions is by using interval notation to describe our set. Here's a set of steps that'll help you through this. You can pause it and write them down if you'd like to. I'm not going to go over them in this video. All right, let's look at the first example. Example 8 it says solve for x. So we have 3x squared plus 5x is greater than or equal to 2. Well, the first thing I'm going to do here is make the right-hand side 0. So I'm just going to subtract 2 on both sides, then I get 3x squared plus 5x minus 2 is greater than or equal to 0. Then I'm going to factorize the left-hand side, or however you can. You're trying to simplify, get the two factors here. So one of the ways I like to do that is if my coefficient is bigger than 1 and I can't divide through by the coefficient, I'll multiply 3 times negative 2. That gives me a negative 6. So I think to myself, what two numbers multiply together to give me negative 6? And what two numbers also add together to give me 5? Well, if you put in 6 and 1, 1 and 6, and those numbers right there will do. So we can factor our expression. I'm going to rewrite this now. Instead of writing 5x, I'm going to write negative 1x plus 6x. That's the same as 5x. Minus 2 is greater than or equal to 0. I haven't changed the value of the expression, just rewritten it. Now I'm going to factorize by grouping, taking out the common factors. And this is equal to, I'm going to take out an x here. So 3x minus 1. And then here I'm going to take out a 2. So 2, that's a plus 2, excuse me. 3x minus 1, right? And then notice that I have two terms that are being multiplied by the same thing, so that's a common factor. So I can rewrite this as 3x minus 1 times x plus 2. All right? That's going to be greater than or equal to 0. And now, this is something that is new, so make sure you take special note of this. This is a sign diagram, okay? A sign diagram means that we're looking at plus and minus. So what I'm going to do, I'm going to draw a horizontal line, number line, and I'm going to put numbers in. Now, what numbers am I going to put in? Well, I'm going to solve for 0 in both of these cases. Remember, one of these, if we set this equal to 0, one of them has to be 0. So 3x minus 1 equal to 0, and x plus 2 is equal to 0. So x equals 1/3, and x equals negative 2. What I'm going to do is I'm going to use these zeros, or these roots, sorry, of the equation, not the inequality, the equation. So I'll put negative 2 here. That means 0 will be like here, and, well, we don't need 0. That means 1/3 is going to be like right there. Okay, so now what we want to do is we want to plug in any value over here to the left side of negative 2. We want to plug in any value in between negative 2 and 1/3. And then we want to plug in any value to the right of 1/3, okay? So for example, I can just plug in any number we want to. I'll plug in negative 3 because it's small. And what you're going to do is you're going to plug this number in to the actual equation, okay? So negative 3, and I'm going to plug it into this guy right here. Okay, so 3 times negative 3 minus 1 times negative 3 plus 2. And that is going to give me negative 10 times a negative 1. And that will be a positive 10. So that number is positive, so I'm going to put a plus sign. What that means is everything to the left of negative 2 will be positive, will be greater than 0. Now, negative 2, between negative 2 and 1/3, I can choose any number. And if you can always, I would always just try and choose 0. So same thing, plug 0 into that equation. 3 times 0 minus 1, 0 plus 2, and you get negative 1 times 2, negative 2. So unlike this that was positive, this one is going to be negative. So I'm going to put a big minus sign. That means everything between negative 1/3 and negative 2 and 1/3 is going to be less than 0. And we have to choose anything to the right of 1/3 here. We'll just choose 1. That's pretty easy. And I get 3 times 1 minus 1 times 1 plus 2. So that's 2 times 3, which is 6, and that's positive. So I put a positive here. And so our inequality, right, our inequality that we're looking at, we're trying to figure out where is this function right here bigger than or greater than 0 or equal to. Well, here and here. So my final answer is x is less than or equal to negative 2, because this guy's positive, or x is greater than or equal to 1/3. Now, the reason that this is equal to, because this right here was equal to. Remember, at negative 2 and 1/3, that it's equal to 0. This equation, if we set it equal to 0, it would be equal to 0 at those points, right? So the reason that we include negative 2 and 1/3 is because our inequality that we're given says also is equal to 0. So your answer will always be given in set notation. You always have to do a sign diagram. And so basically, if you were to draw a picture of this, just a quick sketch, right, what's going on here. You have negative 2, you have 1/3, sorry, this is a bad picture. And so basically, quadratic, it's like a parabola. And so this is just saying, obviously this part is above the x-axis, this part's going to be above the x-axis, and this part right here is below the x-axis. That's it for quadratic inequality.